Are you enjoying the conference as much as I do? Yeah, I know Thomas already told you about VR and AR and JavaScript and how to write VR and AR apps in the browser with React. So what am I doing here? Yeah, Thomas gave you an informative and absolutely entertaining talk about React and React 360, and that's why I want to focus more on the basic principles and share some knowledge about the new WebXR device API and how UX design for WebXR apps work. So, whatever library you will use to write your VR app or AR app, you will hopefully gain a fundamental knowledge about how WebXR works and what to consider when designing a WebXR app. Yeah, or in short, you already had your fun talk about VR and now it's time for the boring stuff. Yeah, of course I think it's a joke. I don't think it's boring at all, but you may decide for yourself. So let's get started. What is WebXR after all? XR basically includes virtual reality and augmented reality and everything in between. So a quick reminder, virtual reality uses a head-mounted display with lenses to show a stereoscopic image to each eye, and it has tracking sensors. And some, like the Oculus or the PlayStation VR or the HTC Vive, come also with 2 gamepads for each hand that also have tracking sensors for rotation and position tracking. You call this like 6 degrees of freedom tracking devices. And with a setup like this, a user is drawn completely into a fully virtual environment that shuts out the real world. Augmented reality, on the other hand, does not draw a user into a digital world, but it rather superimposes the real world or a live view of the real world with virtual content. And this content can be basically anything, like real-time information or data enhancing the real world, or virtual objects looking like they exist in the real or physical world. And last but not least, there's MR or mixed reality, or I have also heard the term merged reality, which is quite fitting. But anyway, the goal of MR is that the digital content coincides and interacts with the physical world. Like, see in this picture, the three-dimensional cube thingy is not like a transparent layer on top of the world anymore, but it adapts lighting and shadows, casts shadows, and yeah, most of all, it disappears behind the chair. Yeah, so as you can see, the X can stand for everything and maybe or probably even for technology we do not even think about today. But what we can do today is write virtual and augmented reality apps with JavaScript for the browser. And therefore the W3C Immersive Web Community Group is working on a new API that is called the WebXR Device API. And this API aims to detect devices with virtual and augmented reality features and to get their individual capabilities. And also the API intends to get a device's orientation and position and then render images to the devices with an appropriate frame rate. This new API is replacing the deprecated WebVR API and it's currently unstable. You can kind of already work with it, but yeah, maybe not for production. But you can maybe even give your feedback to the people writing the API in this status. So, why do we need a new API anyway? What was wrong with the WebVR API? First, the new API now includes functionality for augmented reality as well. And as you can imagine, I guess when writing things twice, the new API is also cleaner and more consistent and more predictable. And promised are also more browser optimizations in regard to performance. For example, they say that you will get 2 times the pixels or the number of pixels within the same frame rate now on a Pixel XL phone. And last but not least, the new WebXR device API exposes an input model that will work across all form factors. Managing input, like we have controllers and one controller, two controller, mouse, and so on, was always a kind of a challenge with the WebVR and the Gamepad API, and now the new API tries to change that. So, okay, let's see it in action. What are the steps we need to do to create a WebXR scene? First, we have to check if there are any devices at all with WebXR features. For example, this could be a modern smartphone working with Chrome and the Daydream view. And then, if a device is available, we want to show our users that our website offers WebXR content. A common way to do this is showing a button to start the virtual or augmented reality content. And then, if a user taps or clicks on the button, we have to request a so-called XR session from the device. And only within an XR session we are able to get the device's tracking information and render images to the device. So, after starting the session and some setup to prepare the rendering, we can start the render loop. And this render loop will continue to produce frames until the user exits the XR mode or until we end the XR session. Okay, so I will show you some code. Let's begin with step 1, requesting the XR device. As I said, an XR device can be basically anything with a screen. On a desktop, you would request, for example, a VR headset like the HTC Vive or the Oculus Rift. And on a smartphone, you could request to render on the display itself, but in a stereoscopic way, like 2 times for the lenses. Or you could not render stereoscopically at all. So to request the XR device, we use the Navigator XR object that has a list of all the XR devices. And the request device method returns a promise that is resolved with the default device if there's one available. And if there's none, the promise gets rejected with a not found error. So with the returned XR device now, we can use the method support session to check if the default XR device actually supports the so-called exclusive sessions, which means exclusive session we require a headset to draw our images on. So if the device is a VR headset, we can draw in a stereoscopic way and the promise gets resolved. And else, again, it gets rejected. Okay, now what we did here is adding a button to the website advertising the VR or XR feature to the user, because an actual XR session, an exclusive XR session at the moment requires a user gesture. So when a user clicks the Start VR button, we can request a session from the XR device with the request session method. And this method has now 2 optional parameters. One is the Boolean to check if we are requesting an exclusive session, and the second is an XR presentation context that is a context of the canvas element we want to draw on. And this promise gets resolved with an XR session object. The object then can be used to get the device's position or information about the user's environment and then present images to the user. So we use the session to initialize everything before starting the render loop. First thing we do is then requesting a frame of reference, and this frame defines where the origin of the 3-dimensional coordinate system is calculated from and what happens to the origin if the devices move. There are currently 3 types of frame of reference. The first, there's the head model, then the eye level I used here, and then there's stage. So head model means that the origin of the coordinate system is approximately like the viewer's head, or hopefully like the eyes, and it stays the same even if the viewer moves. So this is interesting, for example, for devices that can track a user's rotation, but not the position. So for example, the cardboard or the daydream view or the Gear VR. It is also useful to, when you're showing like full sphere or 360 videos and images to the user, because they are also intended to be viewed from a single point. Yeah, this was head model, and now eye level, what I used here, means also that the origin of the coordinate system is the viewer's head, but this time it moves with the viewer. And the last one, stage, means that the origin is like in the center of the floor at the bottom, floor level, and it does not change. And you can use this if you have some kind of room-scaled VR. Like the Vive and the Oculus both have this room-scale VR. The request frame of reference method then returns a promise that gets resolved with an XR frame of reference object. And before starting the render loop, we also need to set up an XRLayer, or to be exactly a WebGL layer. And this layer allows WebGL to provide the bitmaps to be rendered to a device. Yeah. So to set the new WebGL layer, we use a method of the WebGL context of a canvas object. The method is setCompatibleXRDevice. And this also returns a promise, and when it gets resolved, we can create a new XR WebGL layer with the XR sessions base layer method and the new XR WebGL layer method that expects an XR session and the WebGL context. And then finally, we can start the render loop by using the XR sessions request animation frame method. And we will call this method recursively, which makes the function will be called 60 or more times a second. Within the render loop, we can do calculations needed to draw the next frame, like for example getting the device's position, and draw something on the screen if we have a correct position. Also, if your app listens to user input, you would process it here before calling the request animation frame method again. Yeah, and that's basically it. You may want to end the WebXR session either manually or by listening to the XR session's end event, which may be triggered, for example, because the headset was disconnected. And the end method returns a promise that is resolved when the presentation to the VR device has stopped. And once the session has ended, we may want to continue rendering our scene in a non-stereoscopic way by using this time then Windows and request animation frame method. So what we did till now could look like this. See the button and then the stereoscopic image. This is cool, but we may want to support more devices than just VR headsets with a stereoscopic view. So a common solution would be the usage of the 3D scene that works with the gyroscope of a smartphone or with touch and mouse drag and drop input to look around. And this is often called magic window because it has the appearance of a window showing another world outside. So whenever a VR device for stereoscopic rendering is not available or not yet requested, we could show the exact same scene as a magic window. And the cool thing about the magic window mode is that it does not require a user gesture to be started. So we can just render our content to the page when it was loaded without requiring the user to click a button or similar. And to start an XR session for a magic window, we use the XR session creation option exclusive and set it to false. And then again, all the same, we have to set an output context to render on. So with this in mind, we could provide a WebXR app that initially renders a magic window, making use of the smartphone's gyroscope if available, and then we could check if there are VR devices that support exclusive WebXR sessions, which means checking if the user has any VR headsets attached. And if so, we could render a button requesting an exclusive WebXR session to start the stereoscopic rendering on the VR headset. Yeah, let's shortly talk about one of the most obvious problems with VR on the web, or I think, with the web in general, which is the various devices and screen sizes and browsers, operation system, input methods. It's so much. And it means, yeah, I think our users do not always have the optimal hardware to enjoy your virtual reality experience. Not everybody, especially I think when browsing the web, is using a 6 degree of freedom VR headset for it with two 6 degree of freedom input controllers and room scale VR. And not everybody has a smartphone with AR Core or AR Kit support. Your users may also use something like the Cardboard or the Daydream View, like a smartphone, as 3 degree of freedom headset with no input controller or only one. So how do we handle this situation? I would say let's start by making the experience work on devices with less features first, and then improve the experience step by step by using progressive enhancement. With the WebXR polyfill, we can make the code work and run in browsers with no WebXR support. And as I showed you before, we can use the magic window techniques to support hardware on which stereoscopic rendering makes no sense, for example on desktop computers or smartphones without any VR headsets attached. And in the rare cases where even 3D doesn't work at all, we could render a static site with a static image or a video. Yeah, in the future, the WebXR API will also implement functionality for Markerless Augmented Reality. You will be able to start an AR session and get methods to do hit tests with the real world to detect surfaces and planes, and you will be able to set anchors. And these anchors will allow us to specify poses, orientation and position of a virtual object in the real world. So whenever the knowledge of the real world improves, for example by more tracking over time, the anchor can then update its visual position and also improve over time. Yeah, but since we cannot really use these features today, there is a way to create markerless AR in the browser today. And this is by using the AR APIs from Google and Apple, AR Kit and AR Core. They both mainly offer the same feature set. They first have world and motion tracking, then a scene analyzation or environmental understanding like detecting planes, and then a kind of light estimation. And to get access to these APIs, because there's no browser support, we have to use two special experimental browsers developed only for this use case with the great names WebAR on ARKit and WebAR on AR Core. Within these browsers, we can use libraries that will make writing WebAR easier. You already saw React 360 in Thomas's talk, and that's why I want to show you some A-Frame code. Yeah, A-Frame is a library by Mozilla that allows you to write WebVR with HTML tags rather than with WebGL directly. I will show you some code snippets how an AR application with A-Frame could look like. So first let's take a look at the libraries. There's of course A-Frame, which enables us to write a WebGL scene, or to be exactly, it's a FreeJS scene directly in our HTML by using custom A-Frame elements. And then there is FreeJS, the FreeJS extension, FreeARJS by Google, that adds augmented reality features to FreeJS. And the last library, A-Frame ARJS by Chance Labs, adds A-Frame support to FreeARJS. And I also wrote free A-Frame components that I can use in the markup for my specific use case here. There's an intersection marker that it's a small sphere or ball that will show the user if a surface is detected. So it's red when no surface is detected and green when the surface was detected. And then there are two components that will render an AR pet and create its shadow. So within the body tag of the HTML, we can use so-called A-frame entities like HTML tags and attach components to them which give them behavior like HTML attributes. Here, to create an AR scene, we wrap everything within an A-scene tag, and that sets up our 3D scene. And then we can import assets within the asset tag, and this handles all the preloading and asset management for us. And within the scene we have a light source, which is an empty A-frame entity with a light component to cast shadows within the scene. And we have the two custom A-frame components that I wrote by myself. I think this is the cool thing about A-frame. You can use stuff that is already there or that is written by the community, and if you need more, you just extend A-frame with your own component. So last, we need a camera, of course, with an AR raycaster to detect surfaces. For those of you who don't really know what raycasting is, here's a simple illustration. And in our case, it means that we are extending an invisible line from the camera towards the direction the camera looks to check whether the line intersects with other entities, which could be, for example, detected surfaces or 3D objects. And to create a custom A-frame entity, like the intersection marker, for example, we have to write some JavaScript. A-frame has a method first to register your own component, and within the init function we can create elements, set attributes, and attach them to the entity, and with this to the 3D scene. The intersection marker, in my case, should change the color when raycasting recognizes an intersection with a surface, and it should be placed where the intersection was happening. And to do this, we can listen to events from the raycaster components, and then set the sphere's position to the correct point, as well as change the color. And yeah, I guess you can imagine kind of how the code looks like for the raycaster intersection cleared event when there's no more intersection happening. And also the AR pad was developed quite similar. We create an A-frame component and display it with the raycaster's position information whenever a user clicks on the screen after an intersection with a surface was happening. And this is how we can use the raycaster's position value to place the pad on the ground. So here's how it could look like. On the left you see the intersection marker itself for checking surfaces, and on the right you see the pad placed in the scene with some animations. You cannot hear it because I didn't try sound today, but I triggered the animation with the WebGL API, which is, in my opinion, a great way for user input in AR or VR applications, at least when you're using them at home. Yeah, talking about convenient user input in AR, let's talk about user experience design for WebXR applications in general. When you start thinking about user journeys and interactions patterns, you will find out soon that our learned best practices and patterns do not always work in a three-dimensional environment. So you cannot really apply your well-known 2D UX design patterns to your 3D app without any thought. And since 3D, VR and AR within a browser are relatively new use cases, there are no really established UX design patterns yet. But there are some best practices I can share with you. So first, and this is not new, give your users feedback and respond to interaction immediately. So the feedback can be visible or haptic, for example, vibrating controllers, or it can be made of spatial sound, or even you use all the stuff together. And you could also consider the use of a reticle with different conditions for idle, hovering, and active states. Yeah, we are in a kind of similar situation like we were in 2007 or 2008 when the iPhone and with it the use of mobile sites appeared. Back then we had to reconsider how we present our information on a tiny screen or on screens with various sizes and ratios. And now we have to think about how we present our content to a user when there's no more real separation between the user and our applications. It's like our users are finally kind of in our application. And therefore, VR applications do not have a limited viewport, but on the contrary, we have an infinite canvas, but a user has a limited field of view. And of course, this field of view may change because a user can rotate her head and look around. So, how do we make sure a user finds what she or he is looking for? To do this, we guide our users with gaze cues. And therefore, you can, again, use spatial sound, lighting, color, or even creatures with eyes that catch your user's attention. And another tip is that hints are more obvious for your user if you provide them directly in the 3D context and not as a separate text element. Also, it is more intuitive if a user is able to manipulate objects directly in the 3D scene and not via a separate UI element. For example, here the three-dimensional rotation indicator on the right is much better than the text-based hint on the left. Yeah, there's one illustration and one name I am mentioning every time I talk about UX design for VR and AR, and this is Bo Cronin and his hierarchy of needs in VR. And the hierarchy shows that the two most important needs in VR are comfort and interpretability, and only afterwards comes the usefulness and the delight of an application. So, comfort means that a user can use your application without feeling unwell. And interpretability means that the virtual world feels convincing to the user. And if both needs are satisfied, a user gets the feeling of actually being present in your virtual world. And this is what you want to achieve. Yeah, while working on talks and prototypes and projects, I added another point to the hierarchy, which I find sometimes to be even more necessary than comfort, and this is safety. So let's take a look at comfort and safety first in the augmented reality context. One thing you can be sure of is that your user won't use your app in an optimal AR environment. This won't happen. Probably there's not enough space, there are no large empty surfaces, and there are poor lighting conditions. Yeah, you have to accept that you have no control over your scene. So consider these scenarios and make user tests, or maybe even think about adding different features for these situations. And during the design process, it is important to think about your user's context. You should consider the environment your users are using your app in. For example, an app that is mainly used at home can be designed for a longer usage, but an app used outside should support super short interactions. And if your users have to move longer distances, you should introduce it gradually. Yeah, and thinking and testing interactions is important in AR, but as you see also in VR. And to reduce the risk of making a user run into physical objects or even people, avoid encouraging large and sudden movements. And the last tip for a good user experience in augmented reality apps is avoid fatiguing your users. You should respect that holding the smartphone at a certain angle can really be exhausting. So you could consider to reduce the required movement of the device by placing the objects at a certain angle or distance. Yeah, so now what can we do to make our users safe and comfortable in a virtual reality context? First of all, we can avoid creating environments that may trigger phobias like large empty rooms, small rooms, messy spaces, heights, or underwater environments, especially without warning them beforehand. And then you also do not want to move things fast towards the cameras, especially sharp or dangerous things. And you also do not want to attach things near the camera, so a head-up display, as cool as it may sound, is not the best thing to do in VR. And if you want to use splash screens, they should be located in the 3D room and not be attached to the camera. Yeah, and last but not least, respect a person's private space around them. You should not allow objects or avatars or even other users' avatars enter this space. Okay, one last thing we have to talk about when it comes to VR and comfort is simulation sickness. Simulation sickness occurs when our sensory inputs are not consistent. So, for example, when the simulation tells us we are in a car race, but we are just sitting still in a room. There are some best practices you can regard to avoid causing simulation sickness. First of all, you do not want to move the horizon and you do not want to force movement to the user. So, you do not want to move the camera. If there are animated scenes, you could allow additional head movement by, for example, putting the camera on a dolly and then animate the dolly's movement. And second, don't use acceleration. Constant velocity is okay because we cannot feel it, but acceleration and deceleration, so something like this, should be felt, and when there's no feeling, simulation sickness will occur eventually. Also, avoid flicker and blur because they implicate movement, and consider adding a stable focus point to your scene. Some people do this by adding a nose thing in the scene. Yeah, so that's basically all for me today. If I had a free wish, I would like you to remember two things from this talk. So first, respect your users and test your product continuously with real users. And second, if you like experimenting with new APIs, give feedback to the people or persons writing them. So here's a link to the WebXR device API repository, where you can find other interesting documents, for example, an early adopters guide, and most importantly, where you can get feedback by creating issues or just talk to the people. So get involved if you like that. Thank you.